Okay everyone, this is the fourth and last of the video lessons that focuses on working with negatives. And because it's the fourth, I call it lesson 2D. In this case, we're talking about how to divide with negatives. Because the basics of dividing with negatives are so similar to multiplying with negatives, and because I'm assuming, since you're here, that you must have felt pretty confident by now about how to work on multiplying with negatives, I've added a couple of other points in this video lesson besides just the core idea about negatives. A couple of other ideas about how to do division properly in algebra. So why don't you, since once again this is a review, check and see how much you remember about how to do this division work by trying these 12 problems. Hit the pause button. When you come back, I'll show you the answers. Okay, I'm going to assume that you've paused and done this work. Here are the answers to those 12 questions. In particular, these bottom four, I would imagine, might have posed some challenge to folks. As I say, these bottom four questions get at some issues that don't matter so much about negative versus positive, but get at some other lessons. So in fact, there are three core lessons I want you to get out of this video. The first is when to cancel negative signs, and that is the only one that really talks about this concept of working with negatives. The second, it doesn't matter whether it's positive or negative, is the lesson of when to use reciprocals. And then the last is when to know you're done, when to stop. Let's look at that first one, when to cancel negative signs. Well, this box is taken straight from the textbook, the Houghton Mifflin Algebra 1 textbook, and it says the quotient of two numbers with the same sign is positive. So in other words, if you've got negative divided by negative, those negatives cancel out. Similarly, negative divided by negative, the negatives cancel, and it's really just 20 divided by 4, which is 5. But if they're not the same sign, if one's negative and the other's positive, then you're going to end up with a negative result. For example, negative 20 divided by positive 4, the 20 divided by 4 makes 5, but you have to keep that negative sign. There was nothing to cancel it away. So the answer is negative 5. Based on that, you should be able to see which cases are ones where you will end up with a positive result and where you'll end up with a negative. These two negatives cancel, you're going to get a positive answer. There's only one negative in this case, you're going to get a negative answer. Again, there's only one negative in this case, so you're going to get a negative, and here the two negatives will cancel. And so the answer for question 8 will be positive. The second core lesson, and maybe more challenging, certainly relates to more challenging questions usually, is when to use reciprocals. The textbook gives this explanation. A divided by b is the same thing as a times 1 over b. In other words, you can always flip the thing that you're dividing by and multiply it times the top number if you want to. So as an example, if you don't want to do negative 1 divided by 3, you could always flip this 3 and make it 1 over 3. In other words, it would become negative 1 times 1/3, which becomes negative 1/3. I'm not sure this case, for my purposes, makes a whole lot of sense. I don't think I would flip the 3 and make it times 1/3. But here's a case where I definitely would. Whoops, excuse me, didn't mean to move that. Negative 1/3 divided by 4. Well, I would rather see that as negative 1/3 divided by 4 is negative 1/3 times 1/4. Now I can multiply across on the top. Negative 1 times 1 is negative 1. 3 times 4 is 12. And you end up with negative 1/12. Another example, this time with the fraction in the denominator instead of on the top, 1 divided by negative 3/4. That's going to be the same thing as 1 times negative 4 over 3. Hope this is making sense. So now I've got 1 times negative 4, which is negative 4, and 1. Do remember that 1 is the same thing as 1 over 1, so 1 times 3 is 3. And I end up with negative 4/3. Here, let's apply these to the two relatively challenging questions that were in the sample problems at the beginning of this lesson. Let's look at question 9 first. That's the same as 6 times the reciprocal. In other words, negative 2 over 3. Well, let's put a 1 under that 6 so that it's a little more clear. 6 times negative 2 over 1 times 3. 6 times negative 2 is negative 12. 1 times 3 is 3. And you might have stopped on the original batch of questions here, but you really ought to simplify that down and see that that's negative 4. For question 10, 2/5 divided by negative 5/3. Well, it's a whole lot easier to see this as 2/5 times the reciprocal, negative 3 over 5. So now I multiply 2 times negative 3, I get negative 6. I multiply 5 times 5, I get 25. And in this case, I can't simplify down any further. I am done. And in fact, this is the answer I gave as the correct answer for number 10. Speaking of knowing when you're done, knowing when to stop, there are always going to be challenges in algebra as to when to know that you can't go any further. For example, let's look at these two questions. In both cases, it might be tempting to try to separate out this denominator, the 3 and the b, to make it a over 3 plus a over b. It's probably even more tempting to do it in the second one because you've got an a on the top and an a on the bottom. You really want to try to use that canceling skill you learned back in Algebra 1. So you might try to do this. These are wrong. You cannot split a denominator when there's addition between two terms in the denominator, or when there's subtraction. It doesn't matter whether it's addition or subtraction. Don't go splitting these apart. Now, if this had happened to be another number, for example, if this had been 3 plus 7, well, you could have simplified that down. You could have made 3 plus 7 into 10. Then you would have had one term. And then you could have worked with that. But you can't split the 3 and the b into two different fractions. So don't try. Instead, recognize at this point that you're done with both that one in the yellow and that one in the green. That's as far as you can go. We will talk later in the year about the idea of factoring things out of the top and the bottom, but let's not worry about that now. And in fact, there's nothing you can factor out from these. But let's just focus on the idea that the yellow one and the green one are done as is. Okay, if those are the 3 core lessons, let's revisit the dozen questions I gave you at the beginning. Hit the pause button. Try them again. When you come back, I'll show you those same answers. Alright, I'm going to assume that you did that, and here are those answers. If any of this still isn't making sense, don't hesitate to come in and ask me about it. Hit the pause button as you need to look over the answers, but that's the end of the video.